Today, let's solve a common interview challenge, finding the Kth distinct string within an array. It sounds straightforward, but an efficient solution requires a clever approach to avoid redundant checks. Can you pinpoint the optimal strategy? Given an array of strings and an integer k, our task is to return the Kth distinct string in the array. A string is distinct if it appears exactly once. The order matters. We need the Kth distinct string based on its first appearance in the original array. If fewer than k distinct strings exist, we return an empty string. A naive approach would involve iterating through the array. For each string, we then iterate through the entire array again to check if it's distinct. If it is, we increment a distinct count. Once our count equals k, we return that string. This means for every element, we perform another full scan. This nested loop structure leads to an inefficient time complexity of O(n squared, as we're repeatedly searching the array. Space complexity is big O of 1, constant time since we're only using a few counter variables. The key insight here is to avoid repeated scans for distinctness. We can pre-process the array to count string frequencies. A HashMap or dictionary is perfect for this. In our first pass, we iterate through the input array and populate our frequency map, mapping each string to its occurrence count. If a string is already in the map, we increment its count, otherwise, we add it with a count of 1. After this pass, our map holds the exact frequency for every string. Now, in a second pass, we iterate through the original array again. For each string, we look up its frequency in our map. If the frequency is 1, we know it's a distinct string. We then decrement k. When k finally reaches 0, we've found our Kth distinct string and can return it. If we finish both passes and k is still greater than 0, it means there weren't enough distinct strings, so we return an empty string. Let's trace this with an example, array D, B, C, A and k equals 2. First pass, we declare a dictionary. D appears once. B appears once. C appears once. Then B appears again, so its count becomes 2. C appears again, its count becomes 2. Finally, A appears once. Our dictionary now shows D1, B2, C2, A1. Second pass, we iterate the original array. First D. Its count is 1. K becomes 1. Next B. Its count is 2, so we skip it. Next C. Its count is 2, skip. Next B, skip. Next C, skip. Finally A. Its count is 1. K becomes 0. Since k is 0, we return A. The final result for our example is A. This is correct because D is the first distinct string, and A is the second, matching our target k of 2. You'll spot this pattern when a problem asks for counts, frequencies, or unique occurrences of elements, especially if order of first appearance matters. Anytime you need to quickly check element properties without rescanning the entire collection, a frequency map is your go-to. This optimized approach has a time complexity of big O of n due to 2 linear passes. Space complexity is big O of n in the worst case, as our hash map might store all n unique strings. Mastering frequency maps is crucial for many array and string problems. Try the next problem using the same pattern. Don't forget to like and subscribe for more efficient algorithm breakdowns.